Good morning, or maybe afternoon, depending on which class you're in. I'm going to be out sick today, but I wanted to make sure you're behind, so I'm doing a quick video lesson here on section 10-3. All this information I'm going to talk about is obviously in the textbook in section 10-3, so feel free to use that as a resource as well, and you're going to have some homework problems out of there at the end of it, so make sure you're using the textbook in addition to watching this video. We had homework last night on nets. That will be checked when I get back, as well as the new homework for tonight. So we will look at all of that tomorrow, and I should be back in tomorrow. So first couple of things we want to talk about today with section 10-3 are the figures that we're going to be looking at, prisms and cylinders. A prism is a polyhedron, which is just a three-dimensional object with polygons on the sides with exactly two congruent parallel bases. Okay, you're probably most familiar with something like a rectangular prism. A cereal box would be an example. Or sometimes you see a triangular prism. That's actually like the type of prism you might see, the light shining through and producing the rainbow out the other side, like on a Pink Floyd t-shirt or something. A cylinder is a particular kind of prism that happens to be round. A cylinder has two congruent parallel bases that are circles. So something that's cylindrical might, an example might be any kind of like a round container, like where tennis balls come in, or oatmeal sometimes comes in a cylindrical container. You're probably familiar with these. Okay, lateral area. When we talk about lateral, if you're familiar with football at all, you probably think about a lateral being a toss to the side. So that's basically what we're talking about, is the sides of the figure. The sum of the areas of the lateral faces just means the sides of it. Okay, and the total surface area is the sum of the lateral area, that's the sides, and the area of the two bases. Okay, so we'll look at what that actually looks like here in just a minute. These are the formulas that we're going to be using today. I copied and pasted these right off of the formula sheet, which you can look at online, or we'll be getting a copy of it here sometime soon. You'll have access to this when we test on this material, so you don't have to memorize these, but we do want you to try to look at them and kind of make sense of them and understand where they're coming from. That was part of why we did the nets. Over here on the left, we have a rectangular prism. You'll notice that all the sides are rectangles. And for this particular kind of prism, volume can be done with length times width times height, but today we're really focused on surface area. Okay, you see 2LW. That's the bottom and the top. Then you see 2 times length times height. Okay, those are the two sides. The length times height would be like the left side and kind of the back side over here. And then 2 width times height would be kind of on the front right and then the back left sides. Okay, so you can kind of see that this comes from the nets. It's just about, this is just 6 rectangles. 3 pairs of rectangles that all match up with each other. Here's a triangular prism, and this set of formulas actually works for a prism with any particular kind of shape. It could be a triangle, it could even be a rectangular prism. You can use this one if you want, or it could be a pentagon or an octagon or any other shape with a bunch of sides. So you see lateral is just H times P, where P is perimeter of the base. Okay, so if you can find perimeter of that triangle, then you're in business. And you just multiply that times the height, and you have your lateral area, which basically comes out like a big long rectangle that would get stretched around the sides of the thing. So that's pretty straightforward. You see surface area is the HP from lateral area plus 2 times the area of the base, whatever that area of the base happens to be. And if it's a triangle, we get that by doing 1/2 base times height. And be careful with that, because you'll see capital B indicates total area of the base. Okay, but when we do that 1/2 base times height on the triangle, we're talking about the base of the triangle, which would be a length of a side of it. Here's your cylinder. You notice it's round. It's got circles on top and bottom, and it's pretty clear where the surface area formula comes from in that one. 2 pi r squared, that's 2 circles. Okay, that's an area of a circle on the bottom and on the top, 2 of them. And then 2 times pi RH is the lateral area part. So that's the sides of it. The 2 pi r you'll recognize is your circumference, and then the h is your height. So you can actually make a rectangle with the length of 2 pi r, which is your circumference, and the height being correct, and it would wrap all the way around the sides of the thing. So you see bases on top and bottom, lateral faces on the sides. That's all we're talking about. We're talking about lateral area versus bases. Okay, lateral area, if r equals 3 and h equals 8, we're just plugging into a formula here. So we want to refer to our correct formula, and if I switch back real quick, I'm looking at a cylinder. Lateral area is 2 pi RH. And get in the habit of looking at your formula sheets. So 2 pi RH, 2 pi times r times h. So in this case, that's 2 pi times 3 times 8. So you do a 2 times a 3 times an 8. You got 6 times 8, 48 pi. If you want to evaluate that down to a decimal and maybe round it to a whole number or something, you could do it with your calculator. But if you're leaving your answer in terms of pi, you just call it 48 pi. It's just 2 pi times 3 times h, and 2 times 3 times 8 gives you 48. Okay, if lateral area is 10 pi and radius is 3, what is h? So, remember we were 2 pi RH. Now let's just figure out where that must have come from. If it equals 10 pi, really I can plug in that 3 for the r. So 2 pi times 3h equals 10 pi. So what I have is 6 pi times h equaling 10 pi. And now I'm just going to divide both sides by 6 pi. The pi's are going to cancel out. And you're going to have your result for your h by simplifying 10/6. Your pi's cancel here. So you can just cancel them right out. Your 6's cancel, so your h is 1. H equals 10/6, which you could simplify down into 5/3. So if the lateral area was 10 pi and you happen to know the radius was 3, you know that your height must have been 5/3. So this is the thing you might have to do with these formulas, is fill in all the pieces but one and then go solve for it. So you have to use a little bit of algebra skill here. Nothing crazy difficult, but just be familiar with the formulas and willing to play around with a little bit. We're going to find surface area here, and I'll try to move quickly through this. You can always watch these as many times as you want if you find you can read it, but some of you will probably find this to be a little easy side. Remember, we had 2 pi RH, parentheses are a little more clear, plus 2 pi r squared, and the 2 pi RH part was our lateral area, and the 2 pi r squared is 2 circles on the top and bottom, because we're looking for total surface area now. So if r is 6 and h is 12, 6 times 12 is 72, and 72 times 2 is 144. So what I'm looking for in that first part, lateral area, is 144 pi. But then I'm also got to add on the 2 pi r squared. So if r is 6, that's a 36. Times 2 is a 72 pi. And so to finish this thing off, I just have to add 144 and 72. I'm just combining like terms here. So let's see, 144 plus 70 would be 214. So this must be 216 pi. I'm making all my answers in terms of pi here. If you want to convert them into decimals, or if an answer ever calls for you rounding it to a whole number, just put it in your calculator. All right, real quickly, finding the surface area with this triangular base. I'm going to have to calculate what's going on with this side over here. I know my height of the triangle is 3, and I know I got a 5 here, so that tells me, just because I know right triangles, that it's got to be a 4 here, because 3, 4, 5 makes a right triangle. This one, I see a 3 as the short leg, it looks like, and I see a 6 over here as my hypotenuse. What that is telling me is, well, I could do Pythagorean theorem on it, 3 squared plus x squared equals 6 squared, but I remember my shortcuts for my special right triangle rules. This is 3 square roots of 3. This is going to be a headache. 3 square roots of 3. What kind of crazy person set this problem up? Let's turn that into a decimal. I'm not really feeling the 3 square roots of 3. So let's see what they come out to. Looks like 5.2. So I'm going to change that to a 5.2. So what that tells me is that this triangle has a height of 3. It has a base of 9.2, 4 plus 5.2. And I can also get its perimeter by adding the 3 sides. Let's go back and get our surface area formula real quick just to make sure we're getting it right. Be in the habit of following up with your formulas. HP plus 2 times area of the base. HP plus 2 big B. All right, so HP is the lateral area, and in this case, that is going to be 13 times. Perimeter is 9.2 along this side, plus 6 makes 15.2, plus 5 makes 20.2. And then we have to do plus 2 times area of the base, which is 1/2 of 3 times 9.2. Let me pull that back a little so it doesn't wrap around like that. Come on, there it goes. Alright, so this math looks kind of nasty, but it's not going to be as bad as it looks. This 2 and this 1/2 are just going to cancel right out. So really we just need to do 13 times 20.2, and I'll evaluate that on the calculator just to make sure I get it exactly right. That's 262.6 plus 2 and 1/2 cancel 1, but 3 times 9.2. We probably want to check on the calculator. Should be around 27.6. So when I add these together, I'm going to come up with my final surface area of 290.2. So that would be my total surface area. All right, lateral area, I'll just tell you real quickly out loud. You got an 8 here, you got an 8 here. So you're looking at a perimeter of 28. And that's just going to be multiplied times a height of 14. So 28 times 14 is all you need on that one. Here's your homework. It's page 532, numbers 2, 3, 5, 6, 8, 11, 13, and 39. Please feel free to work with a neighbor or a partner, but you each need to end up with your own written work at the end. Write out some steps, especially when you're new to this stuff. It's helpful to jot down the formula as your very first step and then plug into it. All right, good luck.